In this video, we will be using side, side, side and side angle side similarity to show that triangles are similar. So first we'll talk about side, side, side. For side, side, side similarity, if the corresponding sides of two triangles are proportional, then the triangles are similar. So that means that I have to look at the ratios of the corresponding sides and compare them. So if AB over RS is equal to AC over RT, and also equal to BC over ST, then I know that triangle ABC is similar to triangle RST by side, side, side similarity. So if I look at example 1, I want to know whether either triangle DEF or GHJ is similar to triangle ABC. So first I'm going to compare ABC and DEF. I'm going to look at their shortest sides first. So the shortest sides are AB and DE. And AB is 8 and DE is 4, so that reduces to a ratio of 2 to 1. Then I look at their longest sides. So the longest side on ABC is AC, and the longest side for DEF is DF. AC is 12 units, DF is 8 units. Well, that reduces, but not to the same. I have two different ratios. So that means that those two triangles are not similar. So now let's compare ABC to GHJ. So again, I look at the shortest sides. So AB compared to HG is 8 over 16. That reduces to 1/2. Then I look at the longest side. So AC over JG, which is 12 over 24. That also reduces to 1/2. And so my remaining side, the one in the middle, is BC, and we compare that to JH, which is 9 over 18. And that also reduces to 1/2. So since all of them have the same ratio, I can say that triangle ABC is similar to triangle GHJ by side, side, side similarity. So here's an example for you to try on your own. Which of the three triangles are similar? Try to figure this one out yourself. Pause the video now. So the first thing I did was I compared triangle ABC and triangle PQR, and when I looked at the shortest and longest sides, I could see that my ratios did not come out the same, so I know that those two are not similar. Next, I compared triangle ABC to triangle XYZ, and again, I saw by comparing the shortest and longest sides that they were not proportional either. Finally, I compared PQR to triangle XYZ, And they all came out with a ratio that reduced to 5/3. So I know that triangle PQR is similar to triangle XYZ by side-side-side similarity. All right, so example 2, we're going to find the value of x that would make triangle ABC similar to triangle DEF. So first I'm going to figure out my corresponding sides. X minus 3 corresponds to the 20, and the 4 corresponds to the 10, and AC corresponds to DF, or 10 to 2x plus 3. So all three of those ratios should be equal. X minus 3 over 20 is going to equal 4 over 10, and it's also going to equal 10 over 2x plus 3. Well, I don't need to solve all of them, I just need to solve one proportion, so I'm going to solve this proportion here. I'm going to cross multiply, and so when I cross multiply I get 10 times x minus 3 is equal to 4 times 20, and so 10x minus 30 is equal to 80, and if I add 30 to both sides, 10x is equal to 110, and therefore x equals 11. Now I want to make sure that that's going to work in the other part of it. So now I'm going to go back and I'm going to plug that into the other half. So if we put our 4 over 10 again, make that equal to 10 over 2x plus 3, now I'm going to put in the 11 that I found and see if it still comes out to be true. So 4 over 10 would equal 10 over 25. And I can see both of them are going to reduce to 2/5. That's true, and therefore I know I found the right answer. X would have to equal 11. All right, so in addition to side, 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 we also have side angle side similarity. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So again, it has to be the included angle. The congruent angle must be between the proportional sides. Okay, so again, no donkeys. No donkeys looking in the mirror. That's not going to work. The angle has to be between. So here I've got my congruent angles, and so my proportional sides are going to have to be XZ to MP and XY to MN. So if angle X is congruent to angle M, and XZ over MP is equal to XY over MN, then I know triangle XYZ is similar to triangle MMP by side angle side similarity. So let's look at an example where we use this. Okay, example 3, are the top and bottom of the bird feeder similar? I don't know about you, but I don't think this is a very attractive bird feeder. But really all we care about are these two triangles. So I'm going to move them off to the side here. There's one triangle, and there's my other triangle. All right, so I have that triangle ABC has sides of 32 and angle B is 87 degrees, and then triangle DEF has two sides that are 20 and angle E is also 87 degrees. So first of all, I've got my congruent angles. Angle B is congruent to angle E. And so then the question you ask yourself, well, does AB over DE, does that equal BC over EF? And in this case, they give you pretty easy numbers. We've got 32 over 20 on one of them and 32 over 20 on the other. And so because they are exactly the same, I know the sides are proportional. And therefore, triangle ABC is similar to triangle DEF by side angle side similarity. So suppose the top and bottom were equilateral triangles. Would they still be similar? The answer to that is yes, because all equilateral triangles are similar. You know that all equilateral triangles are similar because they all have 60-degree angles. And so you're certainly going to be able to do it by angle because you've got two sets of congruent angles. You also could say all three sides are proportional because you're going to have the same exact ratio because all three sides are congruent. So equilateral triangles are always similar to each other. All right, so example 4. What method would we use to show that the triangles are similar? I need to move this down a little bit. There we go. All right, what method would we use to show the triangles are similar? So first of all, I need to figure out where I've got some proportional sides. So if I look here and I compare 18 to 24, I want to know, does that equal 9 over 12? So I can reduce both fractions. 6 goes into 18 3 times and into 24 4 times. And then 3 goes into 9 3 times and 12 4 times. So they reduce to the same fraction, so I know the sides are proportional. So now they didn't give me the third side, but I do see that I have vertical angles. So I know that angle PRQ is congruent to angle TRS because vertical angles are congruent. And so I've got proportional sides and the included angle between them is congruent. Therefore, I know triangle PQR is similar to triangle TSR by side angle side similarity. Okay, so here's one for you to try and figure out for yourself. Which triangles, if any, are similar, and what theorem did you use? If you do find some similar triangles, write a similarity statement. Pause the video now. So the first thing I checked were triangles ABC and MNO, because I saw that they both had an angle of 105 degrees. So then I checked the proportions on the sides of those angles. The 14 was larger, so I compared it to the 20, and then I compared the 12 to the 18. Well, they didn't come out to the same ratio. So I know those two aren't similar. So then I noticed that in triangle XYZ, they gave me two of the angles. And so if I add those up, I can figure out that my missing angle is 50 degrees. And so that leads me to believe then I notice that I have an angle of 50 degrees over here and an angle of 105 degrees here. So it turns out triangle M and O is similar to triangle Z, Y, X by angle similarity. I wasn't able to use side, side, side or side, angle, side on this one. I had to go back to angle, angle. And that concludes this video. Thank you.